My name is Gary Trenda. I'm the RF applications engineer from Sound Devices. So Sound Devices is based in the United States. If you know Sound Devices, you probably know Sound Devices from location sound, TV, film. The company's been around for 25 years, and for that time has been making a lot of portable devices, mic pre's, mixers, recorders, combo mixer recorders. So that's where the company started. So if you're in that location sound world, you may know us. There's also things like the USB Pre 2 that people use for smart systems, for sound system analysis. And then in 2017, Sound Devices acquired a company called Audio Limited, it was in the UK. And they've been making wireless products for 40 years. And so there are some older Sound Devices wireless products that are in our A10 series that you might have seen. That's, again, TV and film focused. But the newer Astral series of wireless, anything that starts with an A20, is Sound Devices developed product and has, I think, a broader market appeal than just location sound, although it works well for that. Our main manufacturing facility here that we show here is in Reedsburg, Wisconsin. My office is in Madison, Wisconsin, which, if you know the U.S., Madison's the capital city of the state of Wisconsin. That Audio Limited office is in Rickmansworth in the UK, just outside of London. We've got some manufacturing in Scotland as well. So a little bit about the company. We also still service and support everything we've ever made in the 25-year history of the company, which is a big deal for us. So we've got people both in Reedsburg and in Rickmansworth that do component level repair of all of our products. If we can still get parts for it, we'll still fix it. And that's a big deal for us as a company, but also for our users, just to know that you can get stuff fixed if it breaks, and the things are getting used out in the field in kind of rough environments, and you never know what's going to happen out there. I see some interesting things come in with mixers that have been dropped in salt water, or we had one location sound recorder that a fire ant hill had been built around. They were using it for some location recording out in the rainforest. So it's crazy the stuff that gets sent in. But great support from the company. And who am I? Why do you want to listen to me about anything? I'm the RF applications engineer. I've been at Sound Devices since 2021. If you have heard of me before, it probably is from something like the Super Bowl halftime show, which I've done the last 8 of those as one of the RF techs for that event. It's an interesting environment to run, high wireless channel counts in. I was an RF tech and RF engineer for lots of special event type things, music award shows. I worked at Cirque du Soleil for a little bit. I've done frequency coordination for large events. So definitely coming from sort of the user side of things, how are our products used, and how do we help people use them in the field, make things work reliably for them. So I talked a little bit about A20 wireless. That's the Astral series of wireless products. If you go to our display downstairs, you'll see the Nexus and the A20 receiver and our 2 different body pack transmitters, the A20 Mini and the A20 TX. Those are all on display down there. So that's existing wireless product. We're also going to talk a bit about upcoming wireless product today. So we've got some preview of new equipment that was announced last month and will be shipping this year. SuperNexus and an A20 Opto. So we'll talk about that as well. Some of the things that we were highlighting with all of the Astral series wireless. Big point for us is spectra band. So all of our systems have a wide tuning range. All of the receivers do 169 megahertz down in VHF up to 1525, so 1.5 gig. Transmitters will do VHF for the full size transmitter. The smaller transmitter does 470 up to 1525, so everything but VHF. All of the Nexus receivers have a real-time spectrum analyzer built in. And NextLink is what we're calling our 2.4 gig remote control link. We'll go into some more detail with all these bullet points later. But I want to get you thinking about some of the things that the Astral series does. NextLink auto assign, so you can assign frequencies based on your spectrum analyzer view. Gain forward is our marketing term for gain control at the receiver. So what it means is that the transmitter has a very, very wide dynamic range, 130, 140 dB, depending on which transmitter you're talking about. And at that point, we got digital outputs from the receiver. So if you're digital at the transmitter and digital out to the receiver, you can get all the way to your mixing console before you need to adjust the gain, which is where we think people want to adjust the gain and not have to worry about setting a mic pre-level on a transmitter to not clip. That's a definite pain point for me in some of my wireless work. We've got a very wide tuning range, but you also want reliability in a congested RF environment. So we take that 169 to 1525 megahertz tuning range and narrow it down to a 24 megahertz tuning band is what we call it. And those tuning bands are tightly filtered with a SAW filter, which is a very steep roll-off filter. We'll have a slide that talks about that a little bit later. Our Nexus receivers have a single 24 megahertz tuning band. The SuperNexus receiver that we're talking about a bit today will have 3 of those tuning bands, so that gives you up to 72 megahertz of tuning range with 3 different 24 megahertz ranges. There's a Q meter. If you're used to using digital wireless from other manufacturers, you know the advantage of having a quality meter that gives you your signal quality, basically signal noise ratio, and can tell you if you have an interfering signal on channel in addition to just what your RF signal strength looks like. It's a fully digital system, so you've got 10 to 20K audio response, and our transmitters also have onboard recording capabilities. So if you're in an environment where it's not live, if you're going to be providing some of this audio to post-production, you do have the ability to have basically a protect track or a backup recording on the transmitter for all of your mics that are out there. So spectrum band, as we said, 169 to 1525. More operating frequencies. It saves you money, especially if you're touring around. If you're doing a world tour, for example, you might carry 2 or 3 different frequency ranges of all your different mics and in your monitors. And so being able to have one piece of gear that does all of it, bring some spares with you, is less equipment, less rack space, but also just simpler moving between countries to have anything that's legal within that country from 169 to 1525. When you get to a new location, you just set the country on the receiver. You use your phone to set the transmitter because we need location services on your phone to validate that you're in that country to satisfy regulatory requirements. But it's really not any more complicated than opening up an app on your iOS or Android device, Bluetooth connection to the transmitter, and it'll automatically set the country. And again, that filtering gives you good performance within whatever range you're picking inside of that wide tuning range. So talking a little bit about spectrum here in Australia, I know most of you are going to be operating in the UHF broadcast TV band, right? So for you, that's 520 to 694 meg. But there are some alternate frequency bands that are much less commonly used. So VHF TV, for example, and then you've got the LIPD class of devices. So that's the 900 meg systems. And so this Sound Devices system is capable of all 3 of those ranges. And I know TV27, my understanding is that's free of any broadcast TV, so that's a common place to use wireless mics. But anything TV28 through 51, wireless mics are allowed as a secondary user in that broadcast band. So, and the Sound Devices equipment can tune all of it. This is one example of the UK from another presentation I did, but just getting you to think about, here's your core UHF TV band, but here are all your other potential places to tune. And again, for you here, VHF and 900 meg would be that. We talked a little bit about SAW filtering. So SAW filtering, it's a surface acoustic wave filter. This is a 24 meg wide filter, right? And so the thing this fancy spectrum analyzer graph is supposed to get you thinking about is the roll off on these filters. If you're 5-6 meg outside of your tuning range, this filter is rolled off almost not at all. This one's rolled off maybe 10 dB, and the SAW filter's rolled off 40 dB, right? What that means to you in a practical sense is that you can place other strong RF signals like IEMs and IFBs relatively close to where your microphone tuning range is, and your receiver will have the same performance. You'll get the same range out of your wireless mics that you would if they were spaced further away. And as RF environments get more congested, we see more and more people wanting to put mics very close to other strong signals like that. The real-time spectrum analyzer was something we talked a little bit about before. So the idea here is that you have spectrum analysis right on your receiver. And this is just a screenshot from the Nexus receiver. It shows a local DTV transmission, a couple of other spurious transmissions, and then a lot of quiet spectrum up above there. So having that visibility of your wireless spectrum, for me as an RF tech, I used to carry around $5,000–6,000 worth of test gear just to get this kind of view of what's happening in my local environment. So I think having that built into your receiver is a really big deal. And also, the way that the Nexus receivers work, you get this spectrum analyzer all the time. It's not like you have to take one of your audio channels offline and do a scan with it. you could have all of your channels on and operating, and you would actually see all of your operating channels shown on the spectrum analyzer. So you know, these are my mic carrier signals, and then here are interfering signals. It allows you to do something about interference as well, which we'll talk a little bit more about that when we talk about NextLink and how you would control a transmitter and receiver. So there's an auto assign function as well within the spectrum analyzer. You can identify, you could tell it to find you any frequencies within this range, or just band limit it to maybe here to here where you've got clean RF spectrum. And then the auto assign function will automatically do a frequency coordination for you for however many transmitters you're deploying with the system. We talked a bit about gain forward and how that sends the full digital signal across the RF link and then out to your mixing console. Remember to select a mic with appropriate sensitivity. So it still would be possible to say overload a lav mic element, right? And that's why someone like DPA makes a 6060 and a 6061 microphone, because they're going to be different sensitivity levels for what you're doing. So if you've got the appropriate mic on talent, then you don't need to worry about preamp gain on your wireless transmitter. As we said, they can all record 48K 32-bit float wave files. And again, 10 to 20K audio bandwidth. So NextLink. NextLink is our own proprietary long-range remote control. It operates in 2.4 gigahertz, which is good because 2.4 gigahertz is available worldwide without a license, but also can be sort of congested. So that was one of the reasons that we wanted to develop our own remote control protocol. NextLink is very narrow band and frequency hopping. So it hops to different frequencies within the entire 2.4 gigahertz range. So that's like 2400 meg to 2483 meg, and you're hopping to different frequencies within there. And again, from a practical standpoint, what that means is you can send something like a power on command multiple times in a second on multiple different frequencies. And so even if you're in an environment with some interference, one of those signals is going to get through from the transmitter to the receiver. Also, because it's a narrowband signal and because of the type of transmission we're using, it's very long range. In the testing that I've done with it, the range exceeds the audio range. So you'll have dropped audio already from your UHF link, and you'll still have positive NextLink control of your receiver. So even if talent's walked off stage and they're in their dressing room, you should still be able to control their pack, which is going to matter for reasons we'll talk about in a little bit. And it can control all of the features of your transmitter. So really, there is a front panel interface on one of the transmitters. The other one doesn't have a local interface, but for most environments that we're deploying these systems in, you're not going to need to get to talent to adjust settings. You're just going to have your audio assist set out your transmitters, and then whoever is in charge of running your receiver settings can dial all those in remotely. There's also a web browser interface for all the Nexus receivers. And so what that means really is that you've got the same thing that you'll see on the front panel here of the receiver also is mirrored on a web interface. And so as long as you're on the same network, and you can see this is a back panel view. You can think about this display here as here's your front of your A20 SuperNexus, the front of your A20 Opto. Here's the back of the SuperNexus in the back of the Opto. So you've got 4 different network connections on there. It's 2 RJ45s and 2 SFPs. So even if you want to have a fiber optic connection to this from some long distance away, we support that. But your control network just needs to be connected to that RJ45, for example, and then your computer, let's say out at your front of house mix position, needs to sit on that same network, and you can get to the web browser control. And this works well on a laptop or a tablet. On a phone, it scales down, so it's sort of platform agnostic as long as something's on the network. And you can put a Wi-Fi access point on there too to get to your tablet, for example. So we're trying to be very flexible with what you can do with the web interface control for the receiver. Bluetooth control, we talked a little bit about that. It's important for being able to set the country, but if you're in an environment where you're not using NextLink for some reason, you still can Bluetooth connect to any of the transmitters. And from your iOS or Android device, you can get all of the available controls that way as well. So you've got just multiple ways to get to the transmitter, and we're trying to minimize the amount of times that you would have to go actually change settings on the pack. Like we think that at this point, the workflow should be, as long as I can get to the receiver on the network or get physically to the front panel of the receiver, I've got all the control I need over my transmitters. So a combination of NextLink and Bluetooth control for that. I know that's a lot of information. Questions so far? All right. I mean, it's standard Bluetooth, so it's a little more dependent on like your iPhone, for example, than it is on the transmitters, but generally 20 to 30 feet. So if you're close to Talent, you can control settings, but if you need longer range control, NextLink is definitely better in that regard. I mean, as long as you can get audio from the pack, you should have NextLink control to the pack. So the SuperNexus is the latest wireless receiver that, as I said, will be shipping later this year. It's a scaled up version of our Nexus receiver. So the Nexus receiver is a half rack. We had a picture of that before, but I'll show you a different picture. So this is the half rack receiver that is 8 to 16 channels. So the SuperNexus is a full rack receiver that starts at 16 channels and is expandable up to 32 channels. So the way you expand it is just with a license file. So you'd go to the Sound Devices website, input the serial number for your receiver, and then you can purchase 8 channels at a time, an expansion license for it. And really that's because, you know, in talking to customers, we think not everybody's going to need 32 channels right away. But as you add those channels to it, the expansion license will lower your per channel cost on the receiver. So if you do need 32 channels, it becomes a pretty compelling device on a per channel basis. Back panel on here has a ton of different options, and we can talk through some of that based on your interest in all of it. But the things I want to highlight are we've got 6 BNC inputs for antennas there. So that means you've got 3 sets of diversity antennas coming in. So it gives you a lot of flexible options for antenna modes. You've got associated cascade outputs from this, so you can cascade into a second SuperNexus if you want to, or even other wireless equipment. You've got RJ45s. These are actually analog audio and digital audio outputs. So we've got AES3 or analog. That follows a standard called AES72, which is basically how do you map analog audio or digital audio onto an RJ45 jack. You need to use shielded RJ45 cables for that. But other than that, it's pretty straightforward to break that out to XLRs if you need to. I asked our mechanical engineers if we could fit 32 XLRs on the back of a 1RU chassis, and they told me no. So here we are with AES72. But if you don't want to go out analog, you've obviously got a network port. We can come out Dante. We've got 2 different MADI outputs on there. So you've got redundant 32 channel MADI streams. So we're trying to give you a lot of options of getting audio out of this thing. There's 4 different ways to bring audio out. They're all active simultaneously. I see a lot of broadcasters and some other applications where they want, you know, maybe a Dante primary output with an AES or an analog backup path. A lot of consoles now will have a primary and a secondary input to it. And so that's pretty commonly used. Talking a little bit about the antenna inputs. As we said, there's 3 different tuning bands in there. They're each 24 meg wide, so that's 72 total megahertz of tuning range. You could take a single set of antenna inputs like an A1, B1 antenna input, just a diversity pair, run that to all 3 tuning bands, and it would work sort of like a traditional wireless receiver. But let's say you wanted to do something like put one of your systems into VHF. You could feed an A1 and B1 antenna into 2 of your tuning bands and take that 3rd tuning band off of A2, B2, and that could be your VHF antennas. Or even if you wanted to split it up further, you could have VHF antennas, UHF, and 900 meg antennas and feed those 3 in separately. But it gives you a lot of other interesting options. Like you could run 6 UHF antennas into this, and it's something we call hexversity. So now you can put all 6 antennas out and expand your coverage area significantly for like a single 24 meg tuning band. If you're familiar with some of the Shure Axiom Digital Wireless, that has something they call quadversity. So we can't use that term, but you could use 4versity for one set and then split off your other 2, like split 2 antennas off for a diversity zone. So maybe you've got, your kind of mission critical mics, put that in one tuning range, give that one 4 antennas, and then your normal mics with just a diversity pair for the rest of your wireless. So 8 different antenna modes on there, but I just want to get you thinking about there's many different ways to configure it. You can set it up as zoned inputs, like let's say you're in a broadcast studio environment, studio 1, 2, and 3, each gets their own pair of antennas, and that all feeds back to a single receiver. So we're trying to make it so that you have less external equipment for all of your zoning and matrixing and switching of antennas, and it all just feeds straight into the receiver, and we can handle that internally and kind of simplify it for you. SuperNexus questions? Okay. Here's some of the bits we talked about. Again, you can get this slide deck later if you want. And see if there's anything I missed. There's a local word clock in. It'll also take time code. So if you are recording, you can jam time code over that next link and send time code to your transmitters. Your next link antennas can be front or rear mounted. And then this connects right into the A20 Opto expansion chassis, which is this box. Again, it's kind of, here's the lower A20 Opto, but the back panel is the only thing on the Opto that's interesting. So the main purpose of an A20 Opto is to add opticore. So if you're a Digico console user, this will put this right on your fiber optic audio ring for opticore to your consoles. But if you're in an environment where you need additional outputs, we've got more analog and AES outputs here. We've also got a separate MADI, a set of 2 MADI outs, and these 2 MADI outs have their own separate word clock connections. So this is going to be useful if you're in an environment where, let's say, your opticore network is running at 96K, but you're sending a MADI feed to a broadcast truck that needs to be 48K. You can just take that 48K word clock from the truck and give them their own dedicated feed. There's some GBIO on here, which is, I think, future use as much as anything, but any switching that happens on the transmitters, for example, this A20 transmitter has a switch mounted to the top of it. That switch closer could also become a GPIO. So if you wanted to, let's say, connect it to your mixing console to recall a preset or something, it's very useful for that and other things in the future. So here's our Opto information. And then we'll talk a little bit about the outpost. So if you do have a SuperNexus in an equipment rack, and let's say this is, you know, off stage, maybe in a metal enclosure somewhere where these antennas are going to be shielded from your performance area, you can remote your next link using this box, which is an A20 Outpost NL. So this is just a separate next link radio to do your remote control to your transmitters. And this just lives on the control network just like your web interface would. So we've got some flexible input options on this thing. I'll show you the slide for that, where there's an EtherCon connection. There's also an SFP cage on here if you wanted to connect this via fiber if you're a long distance away from the rest of your system. And there's USB for powering it. There's a USB-A for doing firmware updates and such. But we're trying to make this really easy to mount wherever you need it. There's slots in here for strapping it to something. You've got some screw holes. There's all of your different stand mounting options that are common kind of in different places of the world. 3/8, 1/4 inch, 5/8. And that same mounting plates on the bottom. So I'll let you guys pass this around if you want. But the main idea with this is if you need to take that next link remote control and move it somewhere else, you can easily do that as long as it lives on the same control network. So we talked SuperNexus. This is the Nexus, which is kind of half of a SuperNexus, right? It's on the back panel of this. It's got 25 pin connections for your up to 16 channels of either analog or AES out. You've got BNC connections on both the front and the back. You can have a cascade output option with this to feed in the front and go out the back if you need to. Otherwise, you can just use it to switch between whatever is more convenient for how you've got this thing mounted. We're trying to encourage people to think with something like this that you can remote your receiver, put it close to wherever your talent is, and use it as, you know, a remote device where you're able to control it and get audio from it on even a single piece of Cat5 cable, right? This RJ45 on here has Dante and control network and PoE plus input. So if you have a switch or a power injector with PoE plus, that's 30 watt PoE, you can actually power this device remotely. Bring your Dante back to your console and then have that web control maybe right next to your mixing console. And so now it becomes much more flexible. Where can I put this receiver And again, this receiver can do 8 to 16 channels of input and a 24 megahertz tuning band. So it's just another good tool to have in the toolbox as far as when you're designing your system. Do I need to do a traditional rack mounting scenario like this? Which I'm sure a lot of you, if you're doing 32 channels of wireless, are used to having 2 or 3 racks full of equipment to do all that. We're getting that down to just a few rack spaces for everything that you need to do with that, or maybe in conjunction with a Nexus that you can mount somewhere else closer to talent. Yeah, so here's all the details on here. 8 channels, expandable to 12 or 16. Same OLED displays as we talked about on the SuperNexus. Same Ethernet port control, Dante, the web app, and DB25 for your audio outs. That follows AES 59 standard. So it's the Tascam DA88 pinout if you're familiar with that. It's actually an Audio Engineering Society standard pinout now. Smart antenna control on here. I don't know if anybody uses WYSICOM antennas, but they've got antennas that have built-in filter amplifiers that can be remote controlled. So we do support that if you want to control it from the receiver. And there's a USB-A on there. That's initially how you pair a transmitter to make the NexLink work, is with either of the Nexus receivers. You just USB connect between the transmitter and receiver. All of our transmitters have a USB-C port on it, which is multifunctional. For some battery types, it'll actually charge the rechargeable batteries that are in it. There's also a dock available for the mini transmitter. But besides charging it, you can also use it for file transfer. You can also use it for NexLink pairing. Lots of different things. There's a Nexus Go, which is a simpler version of the Nexus. So Nexus is 8 to 16 channels. Nexus Go is 4 to 8 channels. So if you have a smaller channel count need, you can do that. This is a less expensive box, obviously. Interesting on the live sound side of things, I've seen people start using this for like test and measurement, because this body pack transmitter, in addition to having a lab mic input, will do 48 volt phantom power, and we've got a little adapter cable that goes to XLR. So you can plug in your test and measurement mic, have let's say 4 of these, set it out around an arena, bring it back to a Nexus Go and feed that into your smart rig, and it's really fast for doing like a test and tune setup in a a large stadium type environment. But lots of other things you can do with the Nexus Go. There's your DB25 out and your same antenna input. So you can tell them in the back panel on this thing is pretty much this guy with fewer connections, right? All right, before we get into transmitters, receiver side questions, anything so far? All right, cool. 820 Mini is our small body pack transmitter. This is gonna be our most popular transmitter for like a theater application because it's really tiny, it's easy to hide in costumes. There's no user interface on it, so there's nothing for anybody to mess around with on there. You're going to control this with NexLink from your receiver, or if you need to, your kind of second option is your Bluetooth control from the app. Although I'd encourage you to use NexLink in most environments. This takes a Sony NPBX1 lithium-ion rechargeable battery, which can charge in the transmitter, but kind of your backup option for this is 3 AAA size batteries. You need to use lithiums to get the same runtime as the Sony battery, but you could just use regular alkalines in a pinch if you had some problem and just needed to throw something in quickly. It's probably a bigger deal for location sound folks where they get somewhere and their lithium batteries got held up in customs or whatever and they just need to go buy batteries locally. But this also has all of the features we talked about before with gain forward, so you get that full dynamic range. You don't need to worry about clipping at the transmitter. It's got 64 gig of internal flash memory. USB-C is the same as the large transmitter. 4 different RF output levels depending on your regulatory environment. I'm not sure, honestly, what the maximum output is for the different ranges in Australia, but up to 40 milliwatts depending on what your maximum legal transmit power is. There are 2 different modulation types, and this is true for all of our transmitters. You generally want to use long range mode unless you need very low latency, in which case standard mode drops the latency in half from 3.9 milliseconds down to 1.9 milliseconds. And if you do need longer runtime, because a single NPBX1 battery gets you roughly 4 hours at 10 milliwatts, You can double that to 8 hours if you put a different battery door on there. And it's the same transmitter. You literally just push the hinge out and put a different battery door on there. And the battery door holds a second Sony battery. And so it exactly doubles the runtime. This, I think, was originally developed for folks in reality TV who thought 4 hours wasn't really enough. But for most other, I mean, a lot of your theatrical shows aren't more than a 4-hour runtime, right? So it just depends on your use case. The battery doubler might be helpful to you. The holster that comes with it, there's a rack mount charger. This is a half rack wide charger. So you could rack this right next to a Nexus or Nexus Go. You could rack 2 of them together to get 16 chargers. So this is an easy just dock in the charger and charge up overnight. The NPBX1 batteries obviously have a whole other range of chargers for them. So if you did want to have one on the charger while one's in use, you can do that as well. This charger has a built-in USB hub if that's useful for your workflow. If you want to pull files off it or jam time code, you can do that. Otherwise, you can jam time code with the Limo, or we talked about jamming time code over Nextlink. The full-size transmitter just came out last summer. This is a A20TX. So I think the big highlight on here is the mic pre input. So this has that 3-pin Limo connector can do all of these different input options, which is kind of amazing for a full-size body pack transmitter. So your standard lav like mics, but you could send line level in, mic level in just on an XLR. On that XLR connection, you can provide 12 or 48 volt phantom. We'll also take digital in. AS42 is a digital mic standard, which is a little esoteric, but if you're using like a Shep Super Cement mic, that has AS42. AS3 is obviously much more common. Both of these are 2-channel digital standards, so you can record both channels internally on the mic and then decide which of the 2 channels to send across the wireless link if you're using it in an environment where you need stereo. And we've got a proprietary guitar cable, which I'll talk briefly about. But the thing to know about the larger pack is it takes 3 AA size batteries, which is a 14500 size battery. And we're trying to make it compatible with all the different batteries of this size. So besides the alkaline and lithium and nickel metal hydrides that you're familiar with that run 1.5, 1.2 volts, there are also straight lithium ion, like 3.7 volt batteries available in that size. And there's kind of a unique advantage to those in that you could run this unit on 1, 2, or 3 batteries using a 3.7 volt battery. We can charge the 3.7 volt batteries internally. And the runtime on those is really the second best thing to using a lithium primary cell, but those are disposable and very expensive. So for longer runtime, but rechargeable, the 3.7 volt lithium ion, those 14500 batteries have been a real benefit to people, I think. Very long run times. I mean, 12 hours is kind of best case at low power with a lav mic and the lithium primaries, but absolutely, 6 to 10 hours in any of these different configurations that we were talking about before. And the main reason that we do 3 batteries in this is for that 48 volt phantom application where you're eating significant power just powering the mics, and then you might want to have the RF at high power as well. So it gives you great runtime. The display on here is pretty cool. It's a e-ink display, so kind of like your e-readers, Amazon Kindle kind of thing. So even if we pull the batteries out of the transmitter, you still see the display. So I like doing that on here. So if I turn this guy on, you can see the display turns on this way. And you can decide for on and off which, black with white text versus white with black text. You can flip that to whatever your preference is. But with this on and running, if someone were just to accidentally yank the batteries and power it down, you can see it still sticks with whatever's on the display. It only needs power to change what's displayed on here. This will be persistent. So that's super handy for just labeling purposes, right? Where now you know your frequency and your label for this even as you're going through battery changes. It'll save me doing a bunch of P-Touch labels, I think. But also very daylight readable and very energy efficient display. Also a bunch of status LEDs, tells you your power level, tells you if it's muted. This also has USB-C on it, same recording capability as the Mini. Same power levels, same modulation. Rugged aluminum construction. I can pass this guy around. Try out this optional switch on here too, because we spent quite a bit of time on just something that if you've got someone who's using it, they know exactly if this is on or if this is off, and it's very difficult to like accidentally flip it. I mentioned the LEMO to XLR adapter for your balanced line and phantom power needs. And then there's a guitar cable. If you're doing guitar wireless, this is something I didn't think about, but our head hardware designer is also a guitar player, and so I think he kind of just designed this because he thought it was cool. This basically has a DI box built into it. So there's a circuit board inside this 1/4" connection that will adjust the input impedance. So if you're a guitar person, you can do 100K ohm, 1 meg ohm, or 10 meg ohm input impedance to emulate whatever your amplifier or pedal that you'd normally be plugging into presents as an input impedance. So you get that same loading of your pickups and that same tone. And he even added adjustable capacitance to this, so you can emulate guitar cable length. So you can go from 1 to 60 feet of guitar cable emulation as well, which is kind of crazy, but also fun. So like if you're very particular about your guitar tone, this will definitely give you a lot of knobs to turn and stuff to tweak with. We've got a little strap adapter that will bolt onto the back. You can see as this is coming around, there's just 2 threaded holes on the back of this. So you put a plate on there with this sort of like high traction material, and it flips the clip around sideways. So it just goes right under your guitar clip and gives you that orientation that you want with the antenna down. We also have a mic stand mount for it. It's common for folks using boom pole, but again, the test and measurement or any of these applications where you just want to hang this thing right on a mic stand and run the XLR adapter cable up. This is a handy option just to get that mounting plate. All of the Nexus receivers come with a Monarch antenna, which is a wideband antenna. It does 470 to 1525. So that covers the majority of your different tuning bands on the Nexus receivers, which basically means that unless you're doing VHF, you could use this receive antenna on the receiver side, and then you just change the antennas on the transmitters. All the transmitters ship with 3 different lengths, 2 UHF antennas, which is going to cover kind of low and high band UHF TV, because that's a very common core band for most users, and then 1 really long antenna that you can cut down to VHF or cut down to 900 meg or cut it down to 1.5 gig, and you can buy more of those if you need. But generally speaking, if you're traveling with 3 or 4 antennas per transmitter, you've got all the different ranges covered. We do make a slot receiver, which is more popular with like news agencies, stuff that you just want to slot it right onto a camera, or location sound folks are just going to put a small receiver in a mixing bag system. But just want you to know that that's also part of this family. And other than not having NextLink, it supports all the same modulation schemes and tuning bands and ranges that everything else in the family supports. And you can decide what this bottom panel, as far as I/O, if you want, there's a Unislot and SuperSlot is the camera standard, but there's also ways to do XLR or TA3 connections to get audio in and out. And this does have a digital audio output option for AES3. Other bits and pieces, you can get antennas. There's a rack shelf. They're showing you racking 2 Nexuses, but this could rack a Nexus and that charger or whatever you need. And then you can dock it onto one of our mixer recorders if you're a location sound person. This makes it, that's the 12-track recorder shown there. You've got 8 channels of wireless and 12 tracks to record in a little tiny package. That's a big deal for people. So that's kind of the product overview, real briefly, but product questions, stuff we've gone through. All right. Want to know about some wireless audio stuff? Cool. So wireless audio basics. This is not Sound Devices specific. This is just if I'm setting up a whole bunch of RF mics someplace. What do you want to know about digital versus analog? You all are probably well versed in this, but wireless mics a decade ago were primarily analog systems or FM systems using some sort of frequency modulation transmission. And that's generally limited bandwidth, and then you'd have some sort of companding to try and expand the dynamic range of those systems. But generally speaking, that's a much more limited audio quality type of transmission. And so I think you're seeing most manufacturers now transition to fully digital systems, which means essentially that the RF signal that we're sending from the body pack transmitter to the receiver is literally just sending ones and zeros at this point. So it's a full digital, for us at least. It's a completely digital transmission, which really gives you some improvements in performance and fidelity. The big deal that I noticed, because I was an RF tech working out in the field when this transition happened, was the power levels necessary from the analog systems were much, much higher to get reliable operation. Where these digital systems, you can have 20 dB worth of signal and noise and get perfect digital audio quality, where to get really good analog audio quality, you would generally need more than that. And so it took a little getting used to when you're staring at your spectrum analyzer and you see these relatively lower power signals and you're thinking, how is this 5 bars of Q in perfect audio? But it really is just a more robust signal, especially in environments that have some amount of interference, because now it's sort of commonplace to operate digital systems on top of low power digital television transmissions, at least in the areas that I work in. And with analog systems, that was almost impossible. Like, you wouldn't get good audio quality with an analog system in that environment. Also, band planning is something that I try and encourage people to do. It's something that I think we may have been doing intuitively without thinking about it, but really looking at how are we taking our available bandwidth and chunking that up. I gave an example here, and this is going to be super dependent on your local broadcast TV environment, but just the idea that you're going to separate out your wireless mic systems from other things like IEMs and IFBs. We talked about the SAW filtering that these receivers have to try and allow you to place them relatively close together, but still, here as an example, if you're using the low part of your UHF TV band, say 520 to 540 for your microphones, you might leave one TV channel open from 540 to 547 and then start your IFBs there 7 meg up from your microphone range, and then use whatever available spectrum you have here and then alternate that again. You might have different systems with different tuning ranges, but something you want to think about as you're setting up your system is, where am I going to lay out all these devices, and how am I going to make sure that even if I've got a perfect environment where I've avoided all the local broadcast TV, how do I make sure that these systems aren't interfering with each other, or at the very least like decreasing the performance of your mics? Because I get users all the time that will call up and say, my microphone range is terrible. It works, but it's not great. And you start talking about their other systems, and surprisingly enough, they'll maybe have IFB or IEM transmitters right in between their mics in that same tuning range. And that amount of RF noise in your range that you're trying to set up microphones in is just going to decrease the performance of your microphone receiver. And that's true for any system, right? It's sort of like, we're having a conversation in a quiet room. If I turned on a stereo and cranked some music, it just becomes more difficult for you to understand what I'm saying, right? So think about IEMs and IFBs the same way. Like, they're just increasing the RF noise within the range that you want to be nice and clean and quiet for your wireless mics. And then again, we talked about, the low interference devices or Wi-Fi, like, what's going to be in your different ranges, and do you need to coordinate some of these ranges? Like, if you've got a ton of building Wi-Fi, can your control systems work reliably there? We're trying to mitigate that with the frequency hopping nature of NextLink, but I talk to people in environments now where tons of things like lighting control or camera control or other stuff is trying to operate in among Wi-Fi and other systems, and they're all fighting each other for that same spectrum. So think about what's in these ranges and how you can plan it out so everybody gets kind of their own clean, quiet spectrum. For you guys here, the ACMA actually has a pretty reasonable website. I don't know if you guys have seen that, but I will bring that up quickly here just so you can see. As an example, I plugged in the address of Group Technologies here, and it gives me a nice display of what's in the air as far as broadcast TV. So if you're going someplace you haven't been before and operating wireless mics, you can at least get an idea that, well, there's a lot of VHF TV operating here, so I've only really got TV 10 that is potentially open for use for other systems. You'd still want to do a scan here because this is only taking into account broadcast television transmissions, but at least gives you a place to start. And the same thing, we talked before about how TV 27 is generally available nationwide for wireless mics, so 520 to 526 is a good starting point. And then these other ones, if it says likely, what that means to you is that there's a broadcast television station there, but it's further away. And so if you're indoors and you've got some shielding going on, your mics might work. TV32 here is probably in Melbourne, and so you just don't use that at all, but then some of these others are further away. Here's a vacant TV channel. Here's a probably not. And then if you get to the upper end of the range, you see the last 6 broadcast TV channels from 652 all the way up to 694 are likely free of broadcast television here. So it really gives you a good starting point and helps you to start band planning for how you're going to deploy your systems when you get to your event site. All right. So, and then antenna types. What kind of antennas are you deploying? We've got, let's see. I won't run through all of this, but the idea you want to think about is omnidirectional antennas versus directional antennas. And the basic physics of that is you trade off gain for as sensitivity in one direction to being insensitive in other directions. So an omnidirectional antenna is going to cover full 360 degrees around your antenna location, and a directional antenna, now you're going to start to aim it where talent is going to be. And in a lot of cases that's an advantage, but in some cases it may not be. So just think about the pattern of your antenna as you're deploying it. Here's an example of a simple dipole antenna and a fancy view of what that antenna pattern is going to look like. And essentially what we're saying with this is, I think this makes intuitive sense if you think about it. This antenna is not very sensitive directly above or directly below it, but it's very sensitive in 360 degrees around this way, right? And as you start to get into directional antennas, this is a lot of people, I've heard it's called just like a batwing or a shark fin or something like that, but it's a LPDA, log periodic dipole array antenna. And you get some gain in the forward direction where this antenna is aimed, and then it's less sensitive behind the antenna, which again could be an advantage to you if you don't want to pick up an interfering signal that you can place behind your antenna location. Circularly polarized antennas, I don't know if those are super popular for uses here, but I tend to see them more commonly with like in your monitor transmitters. And again with these, most of the popular ones are either 2 turns or 4 turns. The 2 turn is a wider pattern but less total forward gain, and the 4 turn just narrows up and gives you more gain directly in front of the antenna. So, how not to place an antenna? I like that they tried to like set the antennas at 90 degrees to each other so you get some different polarization between those 2 LPDAs. But the story I heard with this was after the installer was done putting in these antennas, this was in some sort of like a sports facility where you've got people playing basketball and that sort of thing. And so somebody came in after him and said, well, we need to protect this equipment, so let's put this metal cage around all of it. And then the contractor obviously got a call to come back and find out why the wireless mics weren't working. So please be aware of what kind of shielding thing you're doing. I mean, again, we talked about that a little bit with the SuperNexus. Like, it's great to have NextLink antennas on the front of this particular rack because they're right in the room. But if I put this inside of a metal equipment rack and closed a metal door on it, all of a sudden the NextLink's not going to work well at all, and you're going to want an outpost. So think about that. Also think about spacing. I mean, these antennas are definitely closer together than they need to be. Generally, in diversity systems, you want to place antennas about a wavelength apart, so that's going to be frequency dependent, but for UHF frequencies, you can think about that as being maybe 1.5 feet or so. Better isn't really worse. If you put it a long distance apart, you can get kind of spatial diversity advantages where you're close to one antenna and then the other one will pick up any dropouts that might happen at your first antenna. Let's see, we got about 10 minutes left, so feel free to stop me with any of this with questions. Also your cabling, I think people don't necessarily think about RF gain throughout their system. And we talked about an antenna that might have 6 dB of gain, but then running from the antenna through to the receiver, how much loss is that? And it's very dependent on a cable. Like I just pulled loss figures at 585 meg, which is kind of, middle-ish of your UHF TV band. And RG58 is probably what you're familiar with commonly using. It's that coaxial cable that's maybe 1/4 inch or so outside diameter. But then, at least for me in the US, Times Microwave is a company that makes LMR, land mobile radio coaxial cable. These 2 cables are the same size, But this one has a construction that's specific for radio transmitter receive. It's double shielded. It's got really, a nice dielectric to it. It's a good cable, right? So this gives you an idea of the difference between just generic cable and good cable. Same rough size, but definitely different loss. So think about the cables you're using and think about the loss. Go look up the spec from the manufacturer about what the loss per frequency is. And if you're going really long distances, think about using big cable. Like this stuff is a little under a 1/2 inch outside diameter, so it's about double the size of this stuff, but you can see the loss is significantly lower. So if I had to go 100 feet, if I had a LPDA antenna that's already giving me 6 dB of gain, and I could use RG8U big coax that's got maybe 6 dB of loss, now I've got unity gain to my receiver. And that could be a good design choice there. If I'm going 150 feet, maybe I pay extra money for LMR 400 UF. But yeah, think about that. And even think about the patch cables within your racks. A lot of the events I do, I'm putting 6-foot patch cables between racks, and that can be a couple dB of loss, and all of it matters. So think about your entire system and sort of your overall RF gain math. I'll also say, like in my experience, using a directional antenna with low loss coax versus using an active antenna that might have an amplifier at the antenna with higher loss coax, I would go without the amplifier if I can, because every time you have an amplifier in line, you want to make sure that before that amplifier stage, you filter it well. Otherwise, you've got the opportunity to overload your amplifier pretty easily. And that makes everything worse if you overload an RF amp. So it's also cheaper a lot of times to use a directional antenna with low loss coax. So cheaper and more reliable seems like a good idea to me. And intermod, I don't know, do you guys want to talk about intermod at all? People talk about, I'm sure you've used different frequency coordination software out there. Sure's Wireless Workbench is really popular because it's free. There's other software packages like EasyRF, IAS, probably some others I'm not thinking of that do frequency coordination for you. But what does that mean? Generally speaking, it means that they're going to do some sort of intermod study, which is just running a bunch of math to say what are potential intermod products that these transmitters are going to generate. But I think the core technical bit that you want to know for this is these intermod products happen because transmitters are close to each other. So if you know that transmitters are going to be 8, 10, 20 feet away from each other, they are not going to generate intermod products. And these slides that I stole from Shure, my friend Tim Veer, who retired from there, did a great job of explaining this. He took 2 older FM analog systems and he said, okay, what happens if they're 8, 4, or 1 or 0 feet apart, right? And so you can see on this slide, if they're 8 feet apart, you've got some weak third order intermod products. That means that the transmitters are seeing each other, and these are your 2 main carrier frequencies, and they're mixing together at the transmitters to produce these. You can think of these as harmonics if you're a music person. It's sort of it's a third order intermod product or a harmonic of those 2 frequencies. And as he cut the distance in half from 8 to 4 feet, you can see those third order products go up. As you're 1 foot away, now the third order products are pretty strong, and the 5th order products are there a little bit. But now when you put the transmitters right on top of each other, all of a sudden you see strong thirds and fifths. So these are more common with analog systems. So you'll hear people tell you that with digital systems you can ignore them. And to some extent that's true. The testing I've done with the Sound Devices wireless system, I can't get them to do 5th order intermod products no matter what I try. And the third order products are weak at a foot, right? They really have to have these things right on top of each other to get a little bit of third order intermod with our digital system. Try this out with your own digital system and look at it on your spectrum analyzer and see. But I think it's an important point that the software is calculating, in a large coordination of 100 frequencies, it's calculating millions of potential intermod products and deciding which ones to avoid, right? So if you have all digital systems, you can probably ignore most of them, and then you really only think about intermod products that are coming from transmitters that are going to be very close to each other. If worn, like 2 body packs on the same talent is a good example of this might be a case where we're going to have intermod. If you're using a old analog system, maybe if you have 2 people standing close to each other. Other than that, I tend not to worry about it too much with the systems, but it's good to kind of understand the fundamentals of this. And if you want to read a ton more about it, Selection and Operation of Wireless Microphone Systems is a really good primer on all things RF mic. questions about that? All right. So that is everything I've got for you. Thanks very much. For all of you guys, if you have questions about Sound Devices Wireless, Scott Jameson here at Group Technologies is going to be your best spot to start. But obviously, if you want to reach out to Sound Devices, you can email support if you want. And that'll get to me eventually if you have a really complex RF problem. So let us know what we can do for you. So thanks.